welcome back. Okay. Somebody hear me in the back? Hello? Hello? Someone hear me in the back? Is it okay? In the back, okay? Yes, yes. Okay here? Okay. Hello? Kind of scary. Good. So, good afternoon. I think we're going to start the first lecture about cell cycle. Okay. This morning we talked about the cell culture, as we mentioned earlier. That is very important technique you need to have to do cancer research. And I encourage you, whenever you have opportunity, join a lab, start having that kind of training. Start to know how to do cell culture. Before I started, here is my information. Many of you could have access to Facebook. Okay, I usually post a lot of recent cancer research news or discovery through Facebook or Twitter, if you have Twitter account. Or the other one is LinkedIn, okay? I don't know how many of you have LinkedIn. And then another one, Pinterest. Pinterest, you could look for cancer hallmark. Okay, so I post quite a few recent cancer research news there. So you're welcome to join me whenever you have chance. Okay, and I think it's very important because these days the news every day we have new discovery, and then we need to keep updated about the research of our in this particular area. Thank you very much. So I encourage you to check that out. Facebook, you type cancer hallmarks, and the Twitter, you could type cancer hallmark as well. As for the Pinterest, type cancer hallmark as well. I even another account for Chinese version that is Weibo. It's a for the sort of another type of a Twitter version. Yeah. So first thing, give you a little bit introduction about our institution. Our institution, UT, University of Texas MD Anderson Cancer Center, is located in Houston. Okay, Houston, Texas. Okay, I don't know if any one of you have visited the United States. Houston is kind of the third largest city in the U.S. And Texas state is the biggest one, biggest state in the U.S. continent. I cannot walk around because Jim told me that I have to stay in the same place. But anyway, our MD Anderson Cancer Center for the last 10 or 15 years has been ranked as the number 1 or 2 cancer center in the United States. And as I said earlier this morning, that this particular cancer center has done a lot in this area in terms of cancer research, in terms of cancer patient care. And about 1/3 of the new cancer drug was done here for clinical trial. And let's say something about our institution. As I said earlier, that our institution has made one major goal is to make cancer history. Making cancer history has two meanings here. So making the cancer become a historical event, no longer to bother us. The other one is why we are here. We are making particular historical step toward to healthy human welfare. Okay, and in the other sense, we have about 1,000 faculty members. We have about 30,000 employees there. And then if you have a chance, we'll welcome you to visit our institution. And I think it's a great place for doing cancer study. And some of you are interested in doing cancer research for your graduate career. You certainly are welcome to apply our graduate school there for PhD program. Yeah. In the past, we have quite a few Vietnamese students through VEF sponsorship come to MD Anderson to study. Yeah. Let me take a look. How many of you are graduate students now? Please raise your hand. Okay. So most of you are undergraduate. Okay. So the situation of if you think that this is your career you want to be, certainly check out our website. You could learn a lot from go to our website. So we're going to start from talking about the cell cycle. In 2001, three important scientists they were awarded a Nobel Prize for this aspect of study. That's including Leland Hartwell from Fred Hutchinson Cancer Center, which is located at Washington University in Seattle. The second one is Tim Hunt. Okay. And the third one is Paul Nurse. And Tim Hunt and Paul Nurse. Paul Nurse was the Rockefeller University president. So all these three important scientists, they have done sort of seminal discovery in this area because the early work, 30 or 40 years ago, or even 20 years ago, we didn't know much about cell cycle regulation. But today, a lot of information coming from those times when they engage in cancer research, engage in cell cycle study, using yeast system, okay? Yeast, so because we talk about a lot of the nomenclature about the gene, they all coming from the yeast genetic study when they identify mutant. For example, when you heard about CDC, CDC stands for cell division cycle, okay? Meaning that they're using the yeast system at that time and then identify the mutant of those yeast, and they will be able to help us understand more about cell cycle proliferation. I like to say something about the cell cycle because I think for us to study cell cycle, it's very important to know that, as I mentioned earlier, that cancer is a disease of cell cycle because the cancer cell is originally coming from the cell undergoing abnormal cell proliferation, okay? And I would like to make an analogy about cell cycle. It's just like you riding a bicycle, as you can see here, okay? No matter what kind of bicycle you want to ride on, okay? A classical one or a kind of tacky one, kind of strange one, okay? Or something kind of funny one. But the two very important elements is there. They are there in order for you to ride on a bicycle, in order to let the bicycle going. As we know, we need a pedal system, right? We need to have a brake because Without pedal, the bicycle cannot move forward. Without the brake, your riding bicycle is very dangerous. Okay, so these two elements always have to be there. And then you could extend that into our car system as well. When you're driving a car, again, you need to have a pedal, a gas pedal, allow the car to move. But at the same time, in order to drive safely, you need to have a brake, right? So without pedal, without brake, driving car is or riding on bicycle are very dangerous. So I like to take these car or bicycle system, the pedal or the brake system, as an important analogy for cell cycle machinery. I call the pedal system of the cell cycle machinery as a positive regulator of cell cycle. I call the brake system of the car or the bicycle as a negative regulator of cell cycle. And these negative regulators or positive regulator of cell cycle, they are very complicated. And so I want to bring you through all these slides. You could appreciate that these are different positive regulator or negative regulator of cell cycle. They are just very amazing to us. Okay. First thing, the pedal system of cell cycle machinery, or sometimes we call it positive regulator of cell cycle. They are a group of protein called cyclin. Okay? Cyclin get a name because they are required during the cell cycle progression. Okay? As you could see, cyclin including cyclin A, B, C, D, E, F, H, etc. Okay? And they have a partner called CDK. CDK get a name called cyclin-dependent kinase. It is a kinase, but this particular kinase, without cyclin, it does not have function. Okay, and you could tell that cyclin A hook up with the CDK1 or